Alright, in today's video we will be reinforcing what was taught in class and using a different example to basically cover almost all of Chapter 3, really. Okay, so we're looking at used Hondas. We have 11 used Hondas, CRVs from 2002 to 2006, as these were prices that were found on CarMax. So the first thing we want to do is do a scatter plot. So we're going to go into our calculator. I've already entered the data into L1 and L2, which, just to refresh your memory to get there, is stat 1. So I entered the data into L1 and L2, and now I want to turn on my stat plot. So I say second y equals. I'm going to turn stat plot on. I'm going to make sure the first one is highlighted and hit enter just to make sure it is. Scroll down, make sure your X list says L1 and your Y list says L2. If they don't say L1 and L2, you just have to press this blue key in either 1 or the blue key in 2, depending on if you want L1, L2. Let's see what this looks like. Zoom 9, which is zoom stat, and here's our graph. Okay, so I have cut and pasted for the calculator purposes on here. I would expect you to be able to do one by hand. Of course, you would label this miles and thousands, and then your y-axis would be costs. Okay? So describe what you see. So we're just looking at it and describing what we see. So I'm going to say it appears to be a strong negative linear association between the miles driven, and I'm going to put thousands in parentheses just so I'm talking in units and in context, okay, and thousands in advertised costs. Okay, calculate the correlation. Very complicated, calculator will do it for you. Stat calc 8. Okay, again, stat calc 8 will give me this linear regression, a plus bx. I hit enter, and I want the r value. And the r is negative 0.8743. So r is equal to negative 0.8743. Alright, interpret the correlation. Now, we're not surprised this is negative. Why? Because this is going downhill. Okay, so I'm not in any way surprised that this is negative. Alright, interpret the correlation. So the correlation confirms that there is a strong negative linear association between the miles driven I'm again going to put in parentheses thousands and advertised cost. I cannot stress enough context. Okay? So the correlation confirms that there is a strong negative linear association between the miles driven and the advertised costs. Okay. The nice part about the video is you can pause it if you need to finish writing that. Alright, next page. By hand, using the formula provided on your reference sheet, calculate the least square regression line. Alright, so we discussed that it's y hat equals a plus bx because we're grown-ups now. So there's some information that we need in order to finish doing this. We need the r, we need the mean of x, I need the mean of y, I need the standard deviation of x, and I need the standard deviation of y. Okay, well the r we already found. The r was negative 0.8743. And now to go find, using the calculator, the mean and standard deviation. So second, calculate. This time we want two variable stats because we want both the x and the y. So I'm going to press number 2 and hit enter. And then I get the mean of x. Wish that came in a little bit clearer. There it is. Alright, so the mean of x and standard deviation of x. And then I'm going to scroll down at my calculator and I get the mean of y. And if I scroll a little bit more, I get the standard deviation of y. So I'm going to copy down those 4 numbers. So the mean of x is 50.4545. The standard deviation of x was 19.2684. The mean of y was 14,425. And the standard deviation of y was $1,899.2812. Take it to the 4th decimal. The more decimals we have, the less error we have. Okay? So now to calculate our slope. Remember, b now is slope. So the formula for that was r times the standard deviation of y over the standard deviation of x. That should not surprise you. Remember, Algebra 1, your slope was the change in y over your change in x. How many up, how many over? The rate of change was y over x. This is the same thing. So now I've got to do negative 0.8743 times the standard deviation of y, which was the 1899. So 1899.2812 divided by the standard deviation of x, which was a 19. So 19.2684. And I am going to let the calculator do that for me. Okay, so I'm going to go to my calculator and do negative 0.8743 times, put in parentheses, 1899.2812 divided by 19.2684. Hit enter. Something's wrong. Negative 0.87. Divided by 19.2. I think I forgot to put the decimal in the right place. There it is. And I get a negative slope of 86.1795. And again, I'm not surprised it's negative because my r was negative. And if you look back on your graph, it's going downhill. So your slope is going to be negative 0.861795. Alright, again, refresher, Algebra 1. We are now going to find the y-intercept. So I have y hat equal to a plus bx. And I'm going to use my means. Okay, I'm going to use my means for my x and my y value here. So I have 14,425 should be a 5 equals a, that's what I'm looking for, plus my slope, negative 86.1795 times 50.4545. And I get 14,425. Again, let the calculator do it for you. And I got negative $4,348.1486. Okay? That's what I got when I multiplied these two together. Now I'm going to add this to this side in order to get a by itself. Again, just a review of algebra. And I got 18,773.14. So that's my y-intercept. So I have a slope, I have a y-intercept, I can write the equation of a line. Y hat equals 18,773 0.14 minus my slope, 86.1795x. Now to put this in AP context, remember y meant the cost. So hat cost, 18,773.14 minus 86.1795 times miles. Okay? So there's the context. Interpret the slope and the y-intercept. So your slope is the predicted price of a used Honda CRV 2002, 2006. Goes down. Why is it going down? Because our slope is negative. Okay, why is it going down? The slope is negative. Goes down by about $86.18 for each 1,000 miles driven. That's it. That's the context of our slope. So the predicted price of a used Honda CRV 2002, 2006, because that's what this was, goes down by about $86.18 for each 1,000 miles driven. See why I kept putting in the word 1,000 everywhere? Because it's 1,000 miles driven. Alright, to interpret our y-intercept, we have what it is, which is about $18,774 or $73. I don't know why I keep seeing a 4. Okay, is the predicted cost of a used Honda CRV for 2002, 2006 with 0 miles. I don't think you're going to find one, but that's what it means. Alright? Calculate the residual plot. Now, your residual plot, I just want you to remind you that your residual is your actual. Residual is your actual minus your predicted. I always remember that AP. Actual minus predicted. Okay? So, again, I'm going to let my calculator do this. I don't want to do all this work. That's a lot. Especially, there's only 11 pieces of data, but imagine a 50-piece data set. Okay? So your calculator will actually calculate the residuals for you. Once you did StatCalc 8, it stores your residuals. I also want to point out that if you look in your calculator, RA is 18,773. That's what we have. And our slope is 86.18. That's, again, what we have. Okay? It stored my residuals once I did this. So I'm going to go to Stat 1. It will do the actual minus the predicted value for me. So scroll up to L3 and highlight. Okay? And then you're going to press second stat. And you get a whole list of things. Scroll down the names. Just scroll them. L1, L2, you're going to get some. Some of you may not have anything here. I have stuff stored. That's why I have numbers here. But see where it says residual? Hit that button. Now your L3 should say L-resid. Hit enter. It's done all the pretty math for you. Did all the subtraction for you. Now let's go turn on our stat plot and see what that looks like. So now we're going to see L1 versus L3. So go back to second y equals, stat plot on, scroll down, and instead of your y list, you're going to put your L3 list, because that's where we put the residuals. And get out of that screen. Some of you might have to quit first. Zoom 9. That's your residual plot. That's what that looks like. Now, your residual plot is used, I'm just going to draw this while I talk. Your residual plot is used to determine if a linear model is the best model to use. That's its purpose. Okay? So, when we're graphing these, what we're looking for is a clear-cut pattern, like a clear parabola, a clear curve. I can sit here and stare at this all day and eventually find a pattern or a curve, but that's not what I'm doing. I'm looking at it quickly and going, yes, there's a pattern, no, there's not a pattern. I don't see a clear parabola. Like, I don't see one clear line parabola. So I'm like, nope, this is a good model. I can use linear for this, and I'm going to move on. So there is no clear-cut pattern. Therefore, a linear model is appropriate. Later on, we're going to see, and you'll know more later, when you're not going to use one, but not for a while. Okay, so that's all I want for this one. So this is a good model. It's appropriate. There's no clear-cut pattern. We're moving on. All right, next question. What is the standard deviation of the residuals? So, what is the standard deviation of the residuals? All right, so again, more complicated formulas. We have already calculated our residuals in n minus 2. We'll see in chapter 12 why we do n minus 2 then, too. So we need the sum of the residuals squared. Sum means we have to add them all together. And then divide by n minus 2, take the square root. Calculator will do it. We've already found our residuals. They're right here. Alright, and our calculator is kind of smart. So you can go to Stat Calc 1. This time tell it to read L3. Alright, so see how I have L3 here? I want my calculator to read the L3 list. So I say enter, and then I get this really big number. See this where it says sum of x squared? That is the sum of our residuals squared, which is what we want. So I get this big 8 million number. So I'm going to write that down. So I'm going to go 8,496,877.66 divided by, now we had 11 cars, so 11 minus 2 is 9. That's where I'm going to get the 9 from. Square root. So back to my calculator. So I put in the 8 million number. I put 8,496,877.66. I hit enter. Divide by 9. Hit enter. And then I'm just going to automatically take the square root button. So that's going to be the second x squared. Okay, so second x squared. Second x squared. So I have the square root button there. And then I'm going to press second answer so that it looks like that. The answer button is that one right there. Okay, so second answer and hit enter. And that gives me $971.65. Remember, this was about money, so $971.65. That's my standard deviation for the residuals. What does that mean? Well, that's the next question. Interpret the standard deviation of the residuals. So, the standard deviation means, on average, the difference of the mean. So on average, the distance from the mean. This is the same thing, it's just the difference of the residuals. So on average, our estimate for the cost of used Hondas 2002, 2006 CRV, because remember, context, will be off by about, and I'm just going to round this, $972. Alright? What is the coefficient of determination? Now this one gets complicated. So, your calculator will find the r-squared value for you. Second, stat 8, enter. There's the r-squared value, 0.7644. Okay, so now I'm going to go back to using my calculator, and I am going to put in to L4 some values. So your SST value is your variation of your Y's. So to let the calculator do that, you're going to go back up there. You're going to tell it to read the Y's, which was your L2, minus your mean, which was 14,425. Hit enter. Now I'm going to go tell the calculator to read stat calc 1. This time I'm going to read L4 and hit enter. And I get a really big number, like 36 million. 36,072,692. So I have my sum of my residuals squared, that was the SSE, divided by the variation of the Y's, that's the 36 million. And when I calculated that, I got 0.2355. Alright, so when I put that in the calculator, I did 849,6877.66 divided by the 36 million, 36,702,000, and I got 0.2355. So I have to subtract that from 1. So I just said 1 minus, oops, I took the calculator off so you can't see it, 1 minus the answer of this whole big number to make sure I didn't cut off any numbers, and I hit enter. And I got 0.7644, which is exactly what our R squared value is, 0.7644. Okay? So what does this mean? So this means that at about 76% of the variation in cost is accounted for by the linear model relating the miles driven in thousands to the advertised cost. Because remember, this is just a prediction line. We're making a prediction. Okay? So we have to, there's going to be variation in it, and that's what your R square explains. It explains that about 76% of the variation in cost is accounted for.